Okay, let's do problem 707, design linked list. In this question, we have to design our own linked list and implement these methods. We can either use singly linked list or doubly linked list, but I will use doubly linked list because it's slightly quicker when it comes to working with the index. So first of all, we have to define our node class. So it will have int file and then node next and node previous, and it will have a constructor. And because there is a method for adding head, adding a tail, we will constantly update our head. So it will be good to have, say, dummy head. But let's just call it private dummy head, and then private dummy tail, and private int size. And when we define our linked list, we will have dummy head equals new node of 0, and then dummy tail new node of 0, and what we'll do is we'll have dummy head and then dummy tail. They will have 2 links, and then when we add another one, say on one node, we will update it so that this points to this points to this. So dummy head done next is equal to dummy tail, and dummy tail dot previous is equal to dummy head, and size is equal to 0. So let's implement probably the easiest ones. So we have get index. So this will get the node in from our list using the index, and then we can get the value of it. And this delete at index will get the node using the index, and then we will for example, if we have nodes like this, we want to get this one, so get method will get node of this one, and then when we want to delete at index, it will still get this, but we can say this node of previous will point to this, and then this will point to this. So we're not really going to remove it, but both methods will return node. So node is equal to node at index. So we need to implement our node at. Likewise, this will get the node at index. So we need helper functions node at index, so that this will return the node. So what are we going to do with get? If it's invalid, we return -1. So invalid means this node will be null. So if return node, if it's null, return -1, else node.var. And delete a node, because this one needs to return, but if the node is null, we don't really need to do anything. So if node is equal to null, we just return. But if it's not null, we need to update our node previous and node.next. So it will be node.previous. So node.previous, next should be node.next. is equal to node.next, and likewise node.next previous is equal to node.previous. Next.previous equals node.previous. And since we deleted it, we have to decrement our counter, the size. So now let's define our node add function. So we said if the index is valid, we'll return null. So if index is smaller than 0 or index is greater or equal to size, we return null. So that has so this node here has size of 5, and if index is 5, if the index I asked for is 5, we return null. And so the reason we use a doubly linked list is, say index was 1. We can search from here, from the left, but if index was 3, we can search from tail. Both of them are well, this one is connected to dummy head, and this one is connected to dummy tail. So if it's 1, we start from here. If it's 0, we start from here. If it's 2, just a personal preference, it can start from either way. But if it was 6, 2 should be worked out from the head. So the condition would be if size divided by 2 is greater than index. So say there are 6 nodes, and if we do divide by 2, we get 3. So that means 0, 1, 2 will be worked out from the head. So we can do node car is equal to dummy head.next. So now this is the current one, and we just loop around until we get the node we are looking for. So int I equals 0, I is less than index, and then I plus plus. Car is equal to car.next. And then we can simply return car. If it's not, we have to start from the tail, so we kind of do the same thing. Node car is equal to dummy tail.previous, and for int I equals, so we are starting from, say this is 5, and then this is 4, and if we are looking for 2, we have to do it once and twice. So I should be size minus 1, and I is greater than index, and then I minus minus, it will be car is equal to car.previous, and then we can return car. I think the bound is bound should be like this, but yes, the bound should be like this. There shouldn't be any other way. Alright, so now we have to implement these 3 methods. So they are both adding a node at the head, at the tail, and at some index. So there should be another helper function that needs to add the number, add the node. So we can call it, oh, by the way, this one should be private. private. It's not gonna return anything. And then let's think about it. If we want to add a head, that means dummy head should be part of the variable, and then dummy head dot next should be part of the variable, so that we can establish a new relationship. Likewise, we need to put dummy tail, and then dummy tail dot previous, and then the new node. There should be like 4 links. So we can have insert between. So it will be node before, node after, and then node. So this node will come between before and after. And it will be before dot next should be node, and then after dot previous should be node. So before, node, after. So we did before the next, and then after the previous. So we need to do node the after, node the next is equal to after, and then node the previous should be before. All right. And then since we added something, we need to increment our size. And node.head should be insert, what was the name, between. So we are adding dummy head, and then dummy head.next, and then new node of file. And adding a tail should be insert between. It would be dummy tail dot previous one, and then dummy tail, and then new node of file. All right, add index. Is there any constraints about add index? Add a node. If the equals the length node will append at the end is greater than length. Okay. All right. So we have to use insert between, but we have to find where in the node we have to add them. So another thing is, if we want to add at 0, what's going to happen is it's essentially same as adding. So whatever is at 0 get pushed over, and then this one goes here. And I think I'm going to reuse the logic for this one. And let's see how it goes. If int, okay, let's remove this one for now. If size minus divide by 2 is greater index, we get the current. Okay, so I'm gonna take this node at current outside, and then we need to node the current, head the next current instead of returning. So for example, if you want to insert a 1, this method will find the node, and then we have to get the 1 before, and then 1. So we are basically, if you want to add index 1, the new node becomes here. So we want to get this and then this. So we've already got this, which is current. So we simply do insert between current.previous and current, and new node of file. And all right, so that's the logic we have at index. So these if and else statements are the reasons why we're using doubly linked list, because, well, it's not necessarily that reason, but it kind of shows that it's going to be much quicker than simply linked list. But I feel like if you want to add a -1, for example, it should also go in as head. So if we do if index is less than 0, we should set it to 0. We shouldn't just throw null. And if index is greater than size, that means it's just wrong, so we just return. And it says so at the end, if it's the same length, if index is equal to size, we can do add at tail and pass in var, and then we can just return. I think that's it. All right, let's submit. Okay, so that's it.